Determine the area of the region bounded by, let's see, x equals minus y squared plus 10 and x equals y minus 2 all squared. So let's start by finding, same thing as all these other problems, intersection points. And let's find intersection points. What's nice is these equations are already solved for x. They say x equals in both. So I can just set the two other sides equal with the y's. So you would have minus y squared plus 10 equals y minus 2 squared. Okay. What should I do next? FOIL out, okay. I get y squared minus 4y plus 4. I'm going to move everything to one side. So I'm going to add y squared to both sides. And I'm going to subtract 10 both sides. Excuse me. 2y squared minus 4y minus 6. That appears again. We should already know how to factor this, I guess. If you divide it by 2 like I did before, you get 0 equals y squared minus 2y minus 3. And it factors 3, 1, minus, plus. So I'm getting the same values as I got before, but now they're for y. Y equals negative 1, y equals 3. If you're looking for intersection points, they're points. So finding just the y values isn't good enough. I need the actual coordinate. So I need to know x. Again, it's your choice. Go up and choose which one of these two functions do you want to plug y into. I don't know. I like the second function a little bit better, maybe. So I'm going to take that one. So it was x equals y minus 2 squared. Plug that in. Negative 1 minus 2 squared. Negative 3 squared, which is 9. So I'm getting the point 9, negative 1. Now plug in 3 for y. Why do I have a, that should be squared. And you'll get 1. So I get the point 1, 3. Okay. So I've got my two intersection points. Let's plot them on our graph. One room. Okay. Okay. So x is 9. Two, 3, 4, 5, 6, 7, 8, 9. Negative 1. 1, 3. Okay. So here's something that's a little bit harder this time, is to get how to fill in this picture. So let's look at our two equations. They were x equals minus y squared plus 10, and the other one was x equals y minus 2 squared. So normally your equations you've solved, they say y equals, right? So in these, the roles of x and y have been switched a little bit, because instead of saying y equals, it says x equals. So if this was correct before, like if this said y equaled negative x squared plus 10, I would know it's a parabola. The minus tells me it's facing down. These are still parabolas. They're just facing left and right now, the mouth of the parabola. In this case, because there's a minus, it's going to open this other way. It's going to open to the left. Okay? But maybe you want a point to plug in so you can see what's going on. The thing that's a little bit different, because x and y, their roles have been changed, you're going to pick a value of y to plug in, and that'll give you a value of x. So let's plug in, you want to stick between your two y values for your intersection points. So y was between -1 and 3. So maybe let's plug in y equals 0 into the first one. If you plug in y equals 0, what am I going to get in this first equation here? X equals 10. So I get the point 10, 0. So this was 9, so 10, 0 is like this. And I said this first equation is a parabola where the mouth is to the left. So I've got enough points here to fill in the picture. This is going to be a sideways facing parabola. So what it should look like is something like this. Okay? So this one is my first equation, minus y squared plus 10. Now let's plug in y equals 0 into our second equation here. Okay? If I plug in y equals 0, what am I going to get for x? X equals, it'll be 4, right? -2 squared, or 4. So I'm getting the point 4, 0. 4, 0. And this other parabola, it's going to open to the right because its coefficient of y squared is +1. So in the end, this is going to look like, let's see if I can draw it here sideways. It goes like this. If you plug in, I also plugged in 2 for y to get this point here. I didn't do that for you, but I also plugged in 2 for y to get that point. And this equation is y minus 2 squared. Okay, we have our picture. I want to do top minus bottom. So look at our picture. The top function changes depending upon where you're at in the region, right? The top is either the black one, or over here, it's the blue one. The bottom also changes depending upon where you're at in the position. Here, at the beginning, the bottom function is your blue one, but then it's going to become the black. So here, the top and bottom functions are not always the same. So this is one where I would integrate with respect to y. Yes.
Oh, that's what I was about to ask, actually.
Yep. Yeah, so I would integrate with respect to y, because remember, if we integrate with respect to y, we, instead of looking top bottom, we look right left. And if I look here, there's always one function on the right, the black one, and there's always one function on the left, the blue one. So it looks like we should integrate with respect to y here, and then our formula becomes right minus left. So I'm going to integrate the function on the right, I said was the black equation, so that's the minus y squared plus 10. So that's going to come first, minus y squared plus 10. And then you're going to subtract the left function, which was the blue one, y minus 2 squared. What are my bounds for this integral going to be? -1 to 3. My range for my y value is -1 to 3. Okay. So when you simplify this, you're going to get minus 2y squared plus 4y plus 6. And you actually get the same exact answer we had in the last one, 64 over 3. I think is the answer. Okay. So the one thing I want to tell you is kind of pay close attention to the region that you've graphed. If you do have this nice top and bottom thing going on, then integrate in terms of x. But if, let me scroll up for a minute and then I'll scroll down so you can finish writing. But if you have this other situation where you always have a right function, you always have a left function, then maybe you should integrate in terms of y instead of in terms of x. It'll make it a lot easier. If you wanted to integrate in terms of x, I'm going to tell you that you would have to compute 1, 2, 3 separate intervals in order to do that. And I don't want to compute 3 intervals, I don't know about you. If I can do 1, then I'd rather do the 1. And that's exactly what happens here.